A step 2 question then, mechanics, 2010 question number 11. It's also question 2 from the step 2 mechanics support module. So as usual with mechanics, we just need to set up the picture super carefully and properly. And as long as we do that, this shouldn't be too bad. So we've got a uniform rod AB. So I've done the entire thing in one go here. AB is across like this. It's got a weight, it's uniform, so the weight acts 2L. So this distance here is 2L along from the thing because it's in the middle, obviously. Angle theta is the horizontal. Its lower end A rests on a fixed support. Now, the fact that it's a fixed support is super important because that obviously means there is a reaction force going straight up, but there's also, you can think of it as a frictional force heading to the right because it's fixed here, which is essentially means it's a lot of friction is being applied to keep it there. You can sort of think of it as in your head, which means the resultant force at A is going to be off in this direction somewhere. And it says that's an angle alpha to AC. It says there somewhere. We've also got a string attached to C, which is 3/4 of the way along. So this distance here is 3L. And that's going to be, the string is obviously got tension supporting it, going in this direction somewhere with angle beta to the rod. So that's everything in the picture, I think all drawn nicely. And we'll just do the usual things that we do in these questions, which is we'll resolve forces horizontally, we'll resolve forces vertically, and we'll take moments somewhere. The most sensible point to take moments from seems to be A, and that's going to be, of course, 2 times L, because W is halfway along this fixed length here. 2 times L, but then we can't use W because W isn't acting perpendicular to the length here. So you've got to use this kind of force here, which will of course be W cos theta, because this angle here is theta. I'm sure you've drawn this triangle hundreds of times, and this is W cos theta. So okay, it's going to be 2L times W cos theta is going to be equal to, because it's an equilibrium, of course, 3L, because C is 3L away, times T. And then what's this force up here? Well, here's 90 degrees, obviously. So I think this is just 90 minus beta. And we can say that thing is equal to that thing, and that will be our first force. Well, not this thing, but 2L times this thing and 3L times that thing, of course. Okay, and then we can resolve horizontally. So horizontally, we have RA. Well, horizontally, that's RA cos alpha plus theta. And then what about vertically? Sorry, what about horizontally the other way? So horizontally down. Well, we have a... sorry, not horizontally down. I mean, horizontally down. What am I talking about? We have RA going this way, of course, and we have to the right, and then to the left, we have this T. And then what's this part of this force here? Well, alternate angle says this is theta here, and then this whole thing is beta, so this little angle here will be beta minus theta. So this here is going to be T cos of beta minus theta, because it's the thing next to this length here. So this here will be T of sine beta minus theta, which I think I'm about to use when we do vertically. So vertically, going upwards, we have RA sine of alpha plus theta, and we also have, like I just said, T of sine of beta minus alpha, which is this little angle in here. So that's going to be the upward ones, and downwards, of course, we have just W going straight down, so there's no need to make a change. And once you're happy that you've got those three set up, again, all this devolves to now, you can see I've got rid of the picture, I've got rid of all the information, I don't care about any of it at all. I'm just going to try and figure out if I can make this look like that. That's all I need to do. And that's basically the majority of this entire question here. So firstly, here, of course, the L's will cancel out, and cos of 90 minus beta, you can do some double angle formulas if you want to, or compound angle formulas. But cos of 90 minus beta is just sine of beta. And you could have actually, if you'd drawn the picture slightly differently, you could have got that straight away. But that's just sine of beta. Cancel the L's, I've divided by 3. I'm actually going to write that all in terms of T, because my aim is going to be, if I look at this equation all the way down here, if I could get T substituted in for W, and then RA substituted in for W, all the W's would just cancel, and then I'd just be down to something that has no T's, R's, or W's in them, which would be fantastic. So okay, let's continue with that plan. Let's rearrange this firstly for RA, I think. Yep, firstly for RA, just dividing by cos of this, and then put this T into there. And now my plan is complete. This bad boy is going to go straight in there. This guy is going to go in there, and of course the W can stay the same. So that's just what I've done now. I've just put all of this guy in there, all of this in there, and then this W's. All these W's are now going to cancel. I think I'm also going to times, just because writing fractions in PowerPoint is annoying, and times by 3 sine beta cos alpha plus theta everywhere, and now it'll introduce a cos of alpha plus theta here, but I don't really care. That's fine, and I'll get all of this statement here. Now here's the smartest thing in this entire question. Once you factorize out 2 cos of theta from this left-hand side, you need to look carefully at the thing that I've just written in brackets. Cos sine plus sine cos, or sine cos plus sine cos. And the angles are repeated the same. This whole thing here is just sine of this one plus this one. Because if I were to expand, if you imagine this one as the first angle and this one as the second, if you expand this out, you get sine of this, cos of this, plus cos of this, sine of this, which is exactly what's written here. And of course, then the thetas cancel, and you end up with something that looks pretty nice. It looks pretty close to getting towards this. The most sensible thing now seems to be to expand out these alpha plus thetas. There isn't anything else that seems like this is a really good spot to do first. I guess if you expanded out everything straight away, it would probably work eventually. I don't know. But from here, I think that's definitely what we should be doing. So sine cos plus sine cos, and this one is the cos cos minus sine sine one. And yeah, then what can we do here? Well, I just expanded out. And then you look at the thing that you've got here. It has cots, tans, and cots. So let's just start dividing, right? Let's just start dividing to give ourselves some cots, tans, cots, and tans. So here's the cos theta, sine theta. So sensible to divide by cos theta, right? Because, okay, first I'm doing beta apparently, because it goes sine beta, sine beta, sine beta, cos beta. So that cos beta is just going to go away. And those three are going to turn into tan betas, which seems, well, actually is not what you end up with, but it seems like a reasonable thing to do anyway. Then I think I'm going to divide by cos theta. Okay, so divide by cos theta, this goes away, this goes away, this goes away. That turns into a tan theta, so that's fantastic. That's a lot of reduction going on. Finally, divide by cos alpha. That becomes a tan, that goes away, that goes away, that becomes a tan. And now we can see some excellent stuff here. We could have spotted it all the way up here, but we didn't, or at least I didn't, maybe you did. We can, these two terms are the same. They're the same up there as well, but these are the same. So we take it away from both sides. And now this is looking very close. Let's just make it look exactly right. If we divide again by tan alpha, so I'm doing too much work here, right? But I'm just getting there nice and slowly. Divide by tan alpha, that goes away. That becomes a cot alpha, that goes away. So there's the cot alpha, we've got it. So that's good. It's also got a 1 in front of it, which is even better. Carrying on from here, we'll next, I guess, divide. Actually, no, we're done. Oh, we're done. Are we done? We just moved this over? Not quite. Oh, sorry, yeah, we divide by tan beta. Yeah, divide by tan beta. That becomes a cot, that goes away, that goes away. And then we just move the stuff over, and we end up with what they wanted us to get. So fantastic stuff. And now the remainder of the question is actually pretty easy. I think I've done it in, again, not a very nice way. Cot, well, tan of 45 is 1, so 1 over tan of 45 is still 1, so that's fine. Tan of 30 is 1 over root 3. Show that alpha is 15. So obvious things to do would be to put those values into here, and we get cot alpha is 2 times 1, which is 2, plus 3 times 1 over root 3. 3 over root 3 is just root 3, right? So we get this. Cot is 1 over tan, so if we just flip this whole thing over, we get this. And if I could show that tan of 15 is this, then I would be done, I think, with this question. So I just need to show tan of 15 is this. Now, there's a few ways you could go about doing that. I did it in not the most sensible, but I think the most fun way, which is just break out the tan double angle formula and say, well, I know what tan, if I make A 15, I know what tan 30 is. I wrote it down a second ago. It's 1 over root 3. So if I say that's 1 over root 3 and cross multiply, I'll end up with this. And now if I move that over to the other side and do some rearranging, this is a quadratic in tan 15. So therefore, just using the quadratic formula, tan 15 is this. So that's minus b. B squared is 4 times 3, which is 12, times 4. AC is plus 4, because there's a minus over 2 times a. This is root 16, which is 4. Divide everything by 2, you get this. And so now I know tan 15 is this, which doesn't match what I was hoping alpha would make. Or does it? Because if you just rationalize this by timesing by 2 minus root 3, 2 times 2 is 4, minus 3 is 1, and then you get 2 minus root 3 over 1, which is what we had here. So therefore, alpha is 15. And this question is done. Thanks for watching.